Hey guys, so at this point you've received your mole map and you probably are not really sure what to focus on. For right now, we're actually going to focus on this mass to mole conversion, and we're going to use that dimensional analysis that we started back using way back in November. And we're going to focus on this conversion factor that's down here, the one that says A, molar mass, from the periodic table. So what I'm going to do is I'm going to show you how to use that information in order to calculate a few things and in order to do the work that you have been assigned for this week. We're going to separate it into two parts. The first video is all going to be on how to find that conversion factor, A, and the second part is going to be all on how to convert from mass to moles. Definitely make sure that you are ready to deal with an exit ticket on how to calculate your molar mass before the end of the week. Okay. So let's do a simple problem. Let's say that we were trying to find the molar mass of water. Water is easy. Different periodic tables are going to have slightly different numbers, but let's say we're trying to figure out water, and we know that the formula for water is H2O. Okay, you're going to have to pardon me because, well, I'm not really supposed to be using my neck as much as I am, so we're gonna have to make it work. Now, if you were to look on your periodic table, I already told you that these numbers on the periodic table were atomic mass units. It happens to also be the same as the mass of 1 mole of particles. Now, that doesn't matter a whole lot to you, except to know that if I wanted to measure out a certain very specific amount of, say, lithium, all I would need to do is to go on the balance and put 6.94 grams of lithium in, and I'd be able to easily calculate the number of atoms of lithium I have. But in the case of water, most of you have seen this formula before, a zillion times before, and so we're going to do an easy one, we're going to do a hard one. This will be the easy one. So you probably recognize that there are 2 H's in this formula and that there is 1 O. And I'm just going to remind you that I put a line underneath that O so that it doesn't look like a 10 when I go back at my notes. So if I look at the periodic table, the number underneath H is 1.008. So that's going to be times 1.008. And I'm going to get a number. And then the number under O is 16.00. You have to be careful about which periodic table you use because different periodic tables are going to give you different numbers. And so your answer will be slightly different. Try to use the periodic table that I passed out to you in class. That way we always wind up with the same numbers. And there isn't a whole lot of confusion as to why, a certain number looks a certain way. But anyway, so if I were to put this into my calculator, I would get 2.016 as the number for hydrogen. That's the mass contributed by hydrogen. And then 1 times 16 is 16. And I would add that together, and I would get 18.016. And if you look on the mole map that we had, do you see how it says blank grams of X is equal to moles of X? That's the place where I would put grams of water is equal to 1 mole of water. Oh, that's a little squished. I'll write that for you in just a second. So that's what it should look like, nice and put together, a little bit neater. Make sure that you always write the number. Make sure you always write the grams and what the substance is. Also, the equal sign, the 1 mole, and the H2O. Remember that any conversion factor must have an equal sign. That becomes very, very, very important to us a little bit later. So it's if you get into the good habit now, you won't have any problems later. And again, this is an easier problem, a problem like H2O. I'm going to do a harder problem in just a second, one that includes something with a parentheses in it. Okay, so this is a harder problem. This is ammonium phosphate. We've learned a lot about naming these things and writing the formulas, and here's why it's so important to be able to interpret the formulas. This 3 that is here applies to everything backwards in the parentheses. So there are 3 tables, if you will. There is 1 tabletop and 4 table legs, but there are 3 sets of tables. So again, there's 3 of the ends, and there's a total of 12 of the H's. Okay, the PO4, there's only 1 of the P because there's no subscript here, and there are 4 O's working backwards. Remember, the subscripts apply to the thing before it. So when we set up the math for this, it's going to look a little bit different, just because you have to consider all of everything that is present. So we would wind up with 3 ends, 12 H's, because 3 times 4 is 12. There's only 1 phosphorus, and then there are 4 of the oxygens. Now, by the time you do this a bunch of times, you're going to start to memorize some of these numbers. But in the meantime, make sure that you always look them up to make sure that you know exactly what they are. So in terms of the ends on the periodic table, the end number is 14.01. We already did the H number in the last problem, but it's 1.008. And I'll make those dots just a little bit bigger for you guys at home. And then phosphorus. If I look carefully there, it's 30.97. And then for oxygen, it's 16. Then we're going to multiply all of these out with our calculator and add them up. You definitely want to do this step by step. You do not want to get into the habit of putting it all in your calculator in one step, because then if you make any mistakes, it'll mess up your whole calculation. So you have 3 times 14.01, and that is 42.03. 12 times 1.008. That's going to be equal to 12.093. 1 times 30, we can just keep that number the same without doing any crazy math. And then 4 times 16, many of you may know that that's 64. And so we're going to add all of those numbers up, and we wind up with 42.03 plus 12.093 plus 30.97 plus 64. And you're going to wind up with 149.093. And remember, our conversion factor for A, that's this one, molar mass, is always going to be blank grams of X. We change X over to the substance, is equal to 1 mole of X. So we have blank grams of X, which is this NH4 parentheses 3 PO4, is equal to 1 mole of, and of course I'm running out of room again, so I'll do it a little bit further down, NH4 3 PO4. And so that is how you find your conversion factor for path A, which what we call our molar mass. Okay. All right. I think that is just about it in terms of how to find that number. And our very next lesson will be on how to use that conversion factor. Alrighty then.